Let's take a look at number 30. It says determine the domain of the function. This is domain of a rational function. Now, rational means a single fraction, and when you throw the algebra part into it and a function, specifically we'll have x's in it basically. So keep that in mind. Step 1. Set the denominator equal to 0 and solve. Now, in some cases, solving here may mean to factor it. Step 2. Put a slash through the equals. So let's use the steps on this one. This one's not a very exciting one. I got g of x is equal to 4x over x times x minus 64. Okay, step 1. Set the denominator equal to 0 and solve. So we'll set the x times x minus 64 equal to 0 and solve it. Now, the zero factor property says if you get 0 on one side and you got the other side factored or written as a product, then you can set each factor equal to 0. So I'll set the x equal to 0 and the x minus 64 equal to 0. And then you solve each one of these. Well, this one's already solved. This one I just need to take negative 64 to the right side, it becomes a positive 64. Now these are the values that cause me problems. If I put these back up in my original function, if I put 0 here, for example, I'd have 0 times something, which gives you 0. If I put 64 in there, 64 minus 64 is 0, and 0 times something is 0. And we can't have a 0 in the denominator. So these are the values we cannot have. That's why step 2 says put a slash through the equals. So x cannot equal to 0, and x cannot equal to 64. Now, sometimes this is written in set builder notation, sometimes interval notation. Let's go see what they're doing. Looks like they're using set builder notation. Now, with set builder notation, what you do is you put curly brackets around it. That's how I can draw a curly bracket. You put an x with a vertical bar, like that. And x cannot equal to 0, comma, x cannot equal to 64. How this reads is the set of all x values, and that vertical bar reads such that x cannot equal to 0 and x cannot equal to 64. Now, if I were to write that in interval notation, if you're curious, it'd go from negative infinity to 0, union 0 to 64, union 64 to positive infinity. Basically, I'll start with negative infinity, goes to your smallest number, then go from your smallest to your largest, then from your largest to your infinity. And parentheses, because it can't include those values, because we can't have 0 and can't have 64. And then unions in between them. Let's see which one that matches. X cannot equal, it's reversed, but that's okay. Looks like A would be our answer. So 30A. Let's go check that. 30A. And it checks.